All right, why don't we go ahead and get started? How's my sound in the back? Can you all in the back hear me reasonably well? Yes? Okay. All right, well, like all presenters, I have a terror that I only have 10 minutes of material, and so I'm milking out the last few seconds before we hit 3:30 here, but let's go ahead and jump into it. I want to thank everyone for coming, and I really mean each and every one of you, because I know that we're up against, I think, another AI keynote, so the fact that you all have chosen to come down the hall and listen to me talk for an hour means a lot, so I appreciate it. Thanks for showing up. I'll just say a word or two about who I am before we dive into what the talk's going to be about. My name's Steve Lane. I've been a FileMaker developer since about the mid-90s. First put my hands on FileMaker Server 3 in about 1996, and have been doing things with it ever since. President and CTO and co-founder at Soliant for the next 5 days. After that, I get to step down and let someone else do some of those jobs. So it's been a good run. It's lovely of the Claris folks to have me back for one more go-round. I've been presenting at DevCon and engaged since about 2001 or so. So I've been up here a time or two. Written a few books on FileMaker. Does anyone remember books? Does this ring a bell? Yeah, we used to have them, right? So back in the day. First book I co-authored with Bob Bowers. It was about a technology called Lasso. Anyone developing Lasso?
Lasso, yeah.
All right, still a few in the room. It was a good technology for the time. So. Recently, I've gone away from development. I've mostly focused on project management, estimation, things like that, how we run projects and make them work. But once the AI craze hit, I decided to dive back in and get my hands a little bit dirty and get under the hood again a little bit. So kind of back to more technical topics here. And I have a few hobbies and passions that I do on the side as well. So hoping to find more time for some of them. That's who I am. Who are you? Well, this talk is for anyone. This talk is for absolutely anyone. I want to make that clear. There's some fine print in the middle of the talk, and it will make the most sense if you have some, let's say, intermediate skill with FileMaker scripts and calculations, and if you have some familiarity with calling APIs from FileMaker using insert from URL. How many folks have made API calls using the, yeah, good, you've all done it, that's fine. It is not necessary, it's not mandatory. It'll be great if you've experimented with some large language models and poked around with them and have some idea of how they do and don't work. I imagine most folks in the room have typed some text into ChatGPT and gotten various results back from it. Is that fair to say? Great. So the fine print can be ignored. You do not need to know any of the under the hood stuff or any of the technical details that I'm going to go into. I'll try to pull that back out to a high level to talk about some of the takeaways. But if you are one of those folks who's interested in internals and in stepping through scripts, we're definitely going to spend the middle of the session just doing that, looking under the hood a little bit. So what I want to talk to you all today about is unstructured data. We're all very familiar with databases, with schemas and field types and all of that, but unstructured data is a very common occurrence, and here's a thing that we can get. Suppose you're an art dealer, and as I do in a hobby space, you browse around on eBay a lot or buy a lot of art on eBay. eBay sellers are wonderful people, but they have no organized way of putting in data about their artwork. They will put in anything and everything. So you may get a chunk of text like this, and it has useful information in it, right? It's got a subject, it's got a medium, it's got an artist, it has a putative date, it's got some measurements, something about the condition, but it's all jumbled in there every which way. And if you're building a database of art or art that's for sale on eBay, you don't have a lot of good options if you're dealing with text like this. You can go in and copy it out your hand by yourself by hand. You can hire somebody to do it. You can try to automate it. How many have written a page-long text parsing calculation to handle cases like this, right? We've all done that, right? And then you change a little something and it breaks and you find another edge case. Exactly. The customer comes back and says, I didn't find this one thing, and so you add some more code and you add some more code. And you end up with a brittle monstrosity that nobody wants to maintain. Or you get a plugin that does regular expressions and you try to figure it out. But it's brittle and it doesn't really work all that well. So this is a common situation. In fact, a client of mine had this exact use case. What would be much nicer is to be able to press a button and have something, say an artificial intelligence, scan through that and say, all right, I found your stuff. Here's the artist bio, birth country, birth year, some information about the artist's background, other things like that. And again, you can do traditional computing and traditional text processing to get some of that information, but it's going to be complicated and it's going to be brittle. The question I came into this with was, can we use a large language model to do this work? The answer is yes, we can. Absolutely we can. With, of course, some caveats, because they're LLMs. And that's really what this talk is going to be about. So there's two pieces to this. One is, first of all, mechanically, how do we make an LLM do this? How do we make an LLM look at a blob of stuff and give us something back that's structured the way we want it? And then the second, and to my mind even more interesting, is how do we know it's telling us the truth? Because they're LLMs, right? And they are a glorious mixture of fact and fiction. So how do we square that with our desire to have actual factual data going into our database? So that's the part that almost interests me a little bit more. I don't think I need this slide because everybody here is our database people. We're at a FileMaker developer conference, but just for the sake of completeness, we are probably all database people here. Machine learning does not make structure obsolete. You've got to have it. If you're doing old school regression, you need structured data. If you are doing analytics and business intelligence, you need structured data. Efficient searching and filtering, the ability to build a database index that will let you search 1 million records quickly, data integrity, compliance, none of that stuff goes away. And I think probably many of you, if you've talked to your clients about LLMs, they've probably said something like they said to me, hey, they're great to play around with, but are they going to really give us actionable business data? How can we trust it? So you've got to have structure. We've got to have databases. We have to have schemas. We need them for all of these things. We need them for system integrations, data validation, quality control, automation, workflows, all of those things. That probably doesn't need much saying, but there it is anyway. So here's our challenge, just to recap it. We're going to take a stream of unstructured data, and we want to reliably extract some key features from that. And we want to be able to render it into a form that's suitable for storage in a database. FileMaker is a relatively forgiving database, as we know. It's not too hung up on character lengths or data types. So we have some wiggle room, and that's a good thing. Nonetheless, it's still got rules, and it still has the need to break data up into pieces and fields and store them in a structured way. And if we do that, then there's all kinds of good automation that we can do. But this is really the question, is can we do this? So let me digress for just 1 minute. I assume that I don't need to say a whole lot to folks in the room about what an LLM is, but let's just go over it for a second, just for fun, because to me an LLM is a highly sophisticated mimic, right? The whole job of an LLM is to produce a response that's plausible, not correct, because that doesn't necessarily mean anything to LLMs. There are probably some AI experts in the room who can refute me on this, so just be nice. But essentially what they're doing is they're taking an input and they're giving you back an output that is a plausible response to that output. And I want to emphasize that idea of plausibility. They are going to generate a response that you would get as if you were talking to a being that possessed factual knowledge. But they don't possess factual knowledge, right? They possess as if knowledge. If I'm talking to someone about FileMaker and I say, hey, first thing you want to do is click on the layout menu, I'm saying that because I've used FileMaker for 30 years and I know for a fact that there's a layout menu. You may have had the experience of asking an LLM for precise technical guidance on a piece of software and gotten something back like, open up FileMaker and go to the action menu. How well is that going to work? Very poorly. Why is that? There is no action menu. But it is a highly plausible response to my question. In other words, if you're an LLM that doesn't know anything but text and you've scanned through millions of responses about software, the idea that FileMaker could have an action menu, absolutely it could, absolutely could. Totally plausible response is just wrong. It's just wrong. It's trained on such large data sets that you get very powerful and often very accurate results. But they're not guaranteed to be correct. So we have to watch out for these plausible but not correct responses, which, as we know, are known as hallucinations in the trade. But what it's worthwhile to remember is that this is a fundamentally different model of computing, right? It's very different. One of my oldest and dearest friends, he's somebody I learned a lot of what I know about computing from. He's basically refused to deal with artificial intelligence. He said, hey, look, I spent the last 40 years learning to write programs that take a precise input and give a precise output. That's what programs do. This stuff doesn't make any sense to me. So he doesn't want any part of it. I respect that. I don't feel the same way, but I understand where he's coming from. He's like, that's not computing. That's something different, and I don't know how to do it. And he's sort of wisely sort of stepping back and saying, it's not for me. But it's here, and it's something that we can learn how to use. But we have to understand that what this engine is trying to do is give us a plausible response, and then see if we can train it to give us a response that's actually correct. And most crucially, check after the fact to see how well it did. That's the part I want to emphasize here. And we're going to come back to that and spend a lot of time on it. OK, so much for LLMs. Just a quick rundown here. This might almost be more than we need. But traditional computing versus LLMs, traditional computing, the input should match the expected format exactly. FileMaker is better about this, but LLMs are better still. None of us has bothered to correct our spelling for years in Google, right? Because Google just reads the misspellings and doesn't care. LLMs are even better at that. I can abbreviate words. I can turn them inside out. I can deliberately misspell them. I'll do that just to try to fool it. You can't fool them. They'll see right through it. So they're very good with messy input, and that's a good thing. Traditional computing, it's sort of either right or wrong. Either it's yes or no. You ask a Boolean question, you get a true-false value. LLMs, they give you a spectrum of confidence levels. If you think about it, that's pretty natural. Sort of the first AI that we all probably had some experience with was Google, where you ask it a question and it gives you a list of not true matches, right? It gives you a list of 10 pages that might be helpful. But we all know not to expect that the exact right answer to our question is in the first page. Might not even be in the second. We'll probably have to comb through 5 or 6 pages, and we'll get some of what we need. So there's a spectrum of stuff, and we're trying to get close. It's a different model, but one we've already been trained on. This is a big one, right? Traditional computing, predictable, repeatable results. If I write a custom function in FileMaker and give it certain inputs, I'm going to get an output. If I give it the same inputs again, I'm going to get the same output. If I do that a million times, I'm going to get the same output unless I change the code. LLMs are different. I can give it exactly the same input, and this is one of the reasons that I'm not running a lot of my demos live, because these people keep changing their engines, and also because you can run the same query 2 times in quick succession and get different results. That's not a bug, it's a feature, but it's very, very different from what we expect from traditional computing. Rules are explicitly programmed. Rules are learned from patterns. Yeah, there's some give in that, but LLMs are scanning bodies of text and doing things that are really known only to them. There are whole branches of AI inside the AI manufacturers where people spend time trying to figure out why the engines do what they do. It's called interpretability. And there are PhDs who try to figure it out. So it's hard to know. Traditional computing fails completely on edge cases, those brittle text parsing calculations. As soon as you find a name that had a space where you didn't expect to find it, you can't find a name. The LLM will degrade gracefully. It will probably find that, and then if you make it garbled enough, then it will slowly stop being able to give you what you want. LLMs have a trade-off between accuracy and flexibility. They can process a great deal of different stuff, highly flexible, and then again, it's this question of accuracy that we're going to come back to. Error checking through validation rules in traditional computing, but then with LLMs, we're going to look at this issue of probability and similarity. How likely is it that this thing that it gave me is what I'm looking for? OK. Let's take a look at what we mean by all that. Let's step away from theory and do a little bit of practice here. Let's get into a demo. Any questions on that so far? We can take a few questions along the way, but if not, I'll just dive right into a demo here. Let's see how we do. All right. So I'm going to apologize in advance for my small text here. I'm going to do my best to narrate it, and I am going to. We'll do this live. We'll see how the room internet holds up, and then if it doesn't, then all the examples are there ready to go. So this is a file that I put together. It talks to a wide variety of different AI APIs. It talks to stability. It talks to OpenAPI. We're just going to be dealing with OpenAPI, in other words, the makers of ChatGPT. I had a grandiose project to do this across 4 different LLMs and compare them. That didn't happen, and I don't think it would have added that much. So this is sort of the flagship. It's ChatGPT, and we're talking to the API behind the scenes here. It's a paid plan. So here, for as well as you can see it, is a big block of text about an artwork that I've scraped off of eBay, actually. And I'm just going to go ahead for right now. We're not even going to get into the code, but I'm going to press my extract button, and I'm going to hope something good happens here. It's going to think about it. Under the hood, it's making a call to open API that we're going to dissect in depth in a minute. And this looks superficially like what we want. I've got my artist. I've got all of this stuff structured in a nice way. I've got its artist's birth year and death year. All of that appears to be information that was back there in the source, so that's reassuring. And there's a lot of stuff in there because I asked for a lot of stuff in ways that we're going to look at. So that looks okay. And then the second step of this is, and this is where we'll spend a lot of time, I want the opportunity to just take a look at what I got and validate that I like it. And all this green and red here is something we'll spend some time explicating. But for right now, imagine that you've got a processor doing this, submitting these requests to a back end. We're getting the structured data, but we do want a human to just check it very quickly and say, all right, well, does this make sense? So this is the validation step. And these colors over here are a clue to how well we think it's being done. When I've talked to customers about this, they're terrified of hallucination. I had an art customer say, they may be in the room, what if this thing hallucinates an offensive name for an artwork for one of my customers? I'll be out of business. And he, absolutely rightly. So some kind of verification or checking here. So I'm imagining that there's an art student or an intern or somebody coming in the morning and looking through these and saying, well, how does it look? And what we're going to do here with some of this visual cueing is we're going to draw their attention to places where maybe the LLM either got it wrong, added something, or added too much. Or maybe they added something that wasn't too much. Maybe it was helpful. We're going to look for that too. Let's now just take a quick look at what's going on under the hood. This is the part where if your eyes glaze over, that's totally fine. There's a demo file. You do not need to understand all the details of this, but I like to see plumbing, and so that makes me like to show plumbing off. So let's take a quick look at it. We're going to drop into the script debugger. We're going to hit our extract button again. We're going to try to do the zoomy thing that I'm starting to learn how to do. So there's a big call stack of stuff here that handles HTTP requests and insert from URL steps. It's fairly abstracted. Don't worry about that. I'm going to draw our attention to the parts of this that matter most. What we're going to do is call to the OpenAI API using insert from URL. So as you can imagine, we're going to build up a data payload that's going to be essentially JSON. There's a few headers that we send for authentication. We have to send out our API key. I'm not worrying about that. The API key is in the background, but we do have one. So we're going to step through. We're going to build up our payload. And we can take a quick look at what that looks like, because this is where some of the interesting work starts to happen. So this is what's going over to the back end. This is what is being sent to OpenAI. First of all, I prompted it by telling it, hey, you're a helpful assistant who understands structured data and values accuracy. So please don't hallucinate so much, right? And then I've engineered a prompt here. I have a header here that is just, again, it's put in behind the scenes. Given the following information, return data extracted from this information about the artwork in a JSON format. I don't know why there's a question mark there. It seems kind of needy. Doesn't bother it, but it's inappropriately vulnerable. Please convert numbers into decimal form. Use only the facts present in the provided information itself. Again, a valiant attempt to get it to not make stuff up. It doesn't work, by the way. If no information exists for a schema element, please provide a null element instead. So that's important. We just know that we want nulls back for any place where it thinks it can't make a call. And then here is the actual record from the database. The data from the database record we were looking at has just been concatenated right in here into the prompt. And that's the prompt. It's this preamble. It's here's who you are. Here's what I want you to do. Here's the data. The second part of this is a big JSON schema. And the reason for this is some of these models are explicitly designed to do this. And in fact, at the time that I was putting this together, OpenAI rolled out their structured outputs mode, I think is what they call it, because they know this is a use case and they want to cater for it. Seeing this response format, let me back up. If I didn't care much about structured outputs, I could just say response format JSON, and it would give me JSON back. But the entertaining thing would be every time I ran it, it would give me slightly different JSON. Right, because it's adapting it and it's trying to figure it out. That's not what we want.
Is that useful?
Well,
You could give it to AI and say standardize the case.
You could, and there's a good case to be made for what happens when we change these things together. And that might even be more efficient. So I don't know if everyone heard that, but the point was made that you could take the output and give it to AI and have it standardize the schema for you. You could do that. But since OpenAI was rolling out this structured outputs technology, I thought, let's give it a try. So seeing response format of JSON schema is our signal to the back end that we want structured data back and we want this JSON schema, not a different one. We're going to choose the element names and specify what we want. This is a whole rabbit hole because OpenAI's JSON schema is, I won't say, it's a little bit quirky. There are some elements of true JSON schema that it doesn't support, and then it is weirdly rigid about some other things. In particular, you have to mark every single element as being required. It doesn't matter, it's not a big deal, it's just something to know. And in fact, the best way to create a JSON schema that's conformant with OpenAI is to have a different AI do it for you, or have OpenAI do it for you. It's just good automation. So this is a very heavyweight schema. I have tried to think of everything I could find in an artwork and put it in here, and tell the engine, if you find something for this, put it in, and if you don't, leave it out. Because all these properties are required, in other words, I was required to make these required, it can't actually leave them out. It's going to put in elements for them, and it's going to leave null values in there for them. I've experimented with other backends, Anthropic in particular, and it's much more flexible. You can hand it a schema. It's not as rigid. But this is where OpenAI, I can't even say this is where OpenAI is today. It's where they were the last time I had the courage to edit the code. But I wanted to keep it working. So that's what's going on there. That, I think, is really all that we need to know about this. We've created this structured request. We've put the JSON schema information into it so that the backend knows, hey, I don't want plain English, and I don't want a JSON structure of your present invention. I want this. I want it in this exact format. And then we step through. Of course, we're setting up a bunch of curl options. We're getting our API key. The curl options, I think, are not very edifying. We can take a quick look at them, but I think they're pretty eye-watering. Let's just take a quick glance for those of you who stay up nights worrying about these things. Yeah, most of that is the escaped form of the JSON schema itself. There's not a lot going on here. It's a post request. We say we're getting back JSON. That's our API key. That's really it. Other than that, it's the stuff that we already looked at. Just a little bit hard to read and process there. So, yeah, and the rest of this is just again, the mechanics of making the call and getting the data back. It takes a minute, right? So you don't necessarily want to be doing that real time. There's a batch option that I haven't fully looked into, but that might be something worth exploring. Was there a question?
Yeah, so you're saying that it was required for you to get back the null, or it's just required for it to work at all when you were working with this?
The required elements at the end there? Right, so the question is, what do the required elements at the end of the schema mean? OpenAI requires you to not have optional elements in your schema because it just doesn't process them for some reason. You're just required to tell it that all of your items are required. It's a weird quirk.
I think it may be better now.
I wouldn't be surprised. I wouldn't be surprised. Okay, so the rest of this just is getting back the data, processing the data, and putting it back where it goes there. So in a way, I feel like I could kind of end the talk there. How do you get structured data out of unstructured data using an API? You send a JSON schema to OpenAPI, and it'll give you some data back. Okay, so far so good. But what about those hallucinations, right? That's where it gets a little bit more interesting. So let's take that question up again. So are we all done? We're not quite done, right? We do have this little issue of hallucinations. Again, customers are rightly afraid of this. And I think one thing to know about hallucination is that it's a feature, okay? It's not a bug. I know that all of the LLM manufacturers are working to minimize it, but because of what LLMs do, it's something that has to happen, right? As far as I know, there's no way around it. And in fact, those rigorous JSON schemas, there's a paper I read that said the more rigorously you tell it what to do, the more likely it is to hallucinate. Did anyone remember the Isaac Asimov iRobot stories?
Yes.
They're very desperate to please their human masters, are they not? And if you tell it to do something, it is going to do everything it can to do it. And if it can't fulfill it with real information, it's going to fulfill it with information that it pulls from someplace else, because you've told it. It's like giving a robot two contradictory orders and watching it do something terrible trying to fulfill both of them. You've told it these data elements are required. And if you tell a robot those data elements are required, it's going to give you data back, come what may. So, well, that's why, I mean, I'd be curious to see if there's a way to relax that, because the less rigorous you make it, the more reasonable the results are. So there's a theory that that's going to, give you more hallucinations in your results. Okay. So
in this what you've done so far, you're kind of on this spectrum of like the better the structure is, the more likely the hallucination is.
it's not so much the better the structure, but the more mandatory it is, right? In other words, I'm not sure yet. I haven't sort of tested the full spectrum of things, but my advice to you, if you want to try this, is start with a lightweight structure. Just start with 4 or 5 or 6 things that you know you have to have. And if there's a million optional things that could happen, try to layer them in and see what you get back. Some of this is a moving target, but you'll see in a minute here some of the other results that we've gotten. These are pretty straightforward. Now, this would not necessarily happen today, but it happened not that long ago. So this is what I put in. I put in just a garbled description purporting to allude to a famous painting by Georges Seurat. I didn't put the name in, and I didn't even bother to spell it correctly. But lo and behold, what I got back was a very definitive schema about this artwork, right? I got Seurat's birth year. I got, anyway, all of this stuff, none of which is in the original. It's absolutely correct. The LLM did what I asked it to do. It supplied information that I didn't have. I might even want it to do this. This might actually be useful. That's up to you in your use case. But it is absolutely not a structured data extract from the original source, which is what the brief was. That's all we want. So there might be a use for this. This might be a powerful feature. In this use case, though, technically, it's doing something I don't want it to do. And of course, I had to push it to the extreme. I just gave it an artist name. And it very confidently gave me back the image dimensions, the image widths, right? All of these various exhibitions, I have no idea whether these exhibitions are true or not, right? Now, look, I'm misusing the robot here. I'm being patently unfair, right? This is tormenting an artificial intelligence. But it's good to know. And for what it's worth, by the way, I think if I press this button now, which I don't want to do because this is now a fascinating historical artifact, I think if I press the button now, I'm going to get something much more sensible back from OpenAI because they are working on this and fixing it. But another model might give you this. And so it's good to be familiar with why this might happen. And the answer is I haven't given it enough information, but I've given it a very big schema and said, fill it in anyway. And it's like, yes, sir, I'm going to fill it in. So we get things like this. And then there might be some things in the middle where it just adds a little bit of information. And so that, I think, is what I want to take a look at next here. What are we going to do about this, right? Some of these are highly reliable, and some of them are highly unreliable. I haven't explained much yet about what all this red means, but it's not a good sign. This is some stuff behind the scenes that we're going to take a close look at that basically say you can't trust this. There's way more information in the supposed extract than there was in the source. So just knowing that that's possible and knowing how to look for it, I think, are the important learnings there. I'm gonna.
Are you going to go over how you're creating that, all the red and green?
I sure will. Yeah, that's going to be sort of the next sort of deep dive there. Was there another question?
Now or at some point, I'm curious
Yeah.
if you'll talk about that temperature coefficient that you gave it. I was shocked that at 0.05 it fabricated so much, and I'm curious what you think is.
You have a laser eye. The temperature parameter. 10 minutes before the talk, I was saying I really should take that off the screen because I'm not going to talk about it very much. But now I have to, and that's fine. So that's an interesting point, and we can come back to it. That's a great catch. Good eye there. Trust but verify, right? Obviously, this harks back to the Cold War. It's a term that we know from the nuclear era, but it's probably good advice for any dangerous technology. And I think it's fair to say that LLMs, to me anyway, are dangerous technology. So the question here is, how do we check LLM output for hallucination? Well, my first thought was, well, I'll just ask the LLM to validate itself. How well do you suppose that worked?
Inmates in charge of the asylum.
What's that?
Inmates running the asylum.
A little bit, yeah. Well, it worked to exactly the same way that the original extract worked. In other words, it very confidently said in some cases that's a hallucination, and it was right. And in other cases, it said that's not a hallucination, and it was wrong. So I'm not enough of a computer scientist to prove this, but I think it's like some sort of first law of thermodynamics or computing. You can't validate a computing technique using the same computing technique that you're trying to validate. So what are we going to do? We're going to use some other techniques. I'm going to dig back into some 20th century computing techniques, things from information theory, which you need to know nothing about. And we're going to try to use those to just kind of see if we can catch cases where hallucination may be going on. We're going to use some information theory. We're going to use some similarity metrics. We're going to use anything that's not another LLM, basically. What these are going to do, and I'm just going to ask you to bear with me over the next few slides because it's a little bit eye-watering. These metrics are not really looking at the content. That's not true. One of these metrics is not really looking at the content. It's just trying to assess how much stuff is in this. And if there's more stuff coming out than there was going in, then something's been added to it. That's the theory. And then similarity metrics are going to look at the content, but at a very low level. They're going to sort of compare word by word and say, how many of the words over here can I find over there? So in that respect, it's a very, very crude, but surprisingly effective technique. Again, I know I'm saying it a lot. Don't need to understand the specifics. They're encapsulated in a bunch of fairly eye-watering custom functions. But the gist of this is find something independent, something outside the LLM that gives you a clue as to whether and how much it's hallucinating. So technique number one. Technique number one, we're going to measure something. We're going to measure something called entropy. Entropy is an old measure from I think the 50s or the 40s of the last century. And it's a metric that tries to assess how much total information is in an information stream. And it's often thought of as how surprising is the next entry. So here's a way to think about it in a FileMaker context. Imagine that you have a database of personal names with 1 million rows in it. And you click into the first name row and you do the Command or Control-I to show the index, right? And most of us are familiar with that. You're showing the index, and lo and behold, there's only 3 names in it: John, Sheng, and Latrice. So 1 million database rows, but there's only 3 different names in that column for whatever reason. So that's interesting. There's not a lot of different names in the database. You start to go through it, and you get John, 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 a lot of Johns. You get some Shengs, and you get some Latrices. By the time you get to the 500,000th database row, how surprised are you going to be by the next first name you see? Not at all. You will have seen them all long ago. There will be 0 surprise. So the surprise factor in that column is relatively low. Now suppose instead you did the show index and you found 754,811 unique names. By the time you get to the 500,000th row, how surprising is the next one going to be?
Could be fairly surprising.
It could be fairly surprising. So there's a lot more information in that column. And just as a sidelight, what's interesting is this has a lot to do with compression. The higher the entropy of your data, the less compressible it is. That's why images are not very compressible losslessly, because this pixel doesn't give you a very good clue at all about what the next one is going to be. But that database column with only 3 unique names in it has very low entropy, and what that means is it's highly compressible. Repetitive data is much more compressible. So this is just a math problem. If you want to look up Shannon entropy in Wikipedia, it will tell you how to solve the math problem, and then you write a custom function in FileMaker to do it. What kind of results do you get? Entropy is a number that is expressed in bits per character, and it ranges between about 0 to 5 for English text. So if I take the entropy of a chapter of Dickens, it's about 4 to 4.5 bits per character. I don't know much more about what that means than you do, but I don't need to, because it works. So what I do is I take the measure of the average entropy, and then I multiply it by the length, just so that the length is factored into it. So what's going on over here down here, big old wall of text, but what it says is that the extract has an information ratio of 1.04 compared to the original. So what did I do here? I took the entropy of the original using these custom functions that I wrote, taking the logic straight off Wikipedia. I compared that to the entropy of the extracted data. I have something that strips the JSON Chrome out of it because all that stuff is repetitive, but we're just looking at the raw bits of the data. And basically I say, how does the information content of this compare to the information content of this? It should be about the same or smaller. It should not be much bigger. This one is slightly larger. So there's probably been a few words or spaces or a couple of extra things maybe added to some of these narratives, but not very much. I set some arbitrary ratios. I basically said, hey, once you get over 1.5, I find you to be suspect. Totally arbitrary number that I made up. And anything below that, it suggests that this is probably a subset of that, which is what we want. That's what we want, for all of this to be a subset of all of this in an information sense. Okay?
Do you ever put it too low a number ever be encountered or be surprised, like, oh, it's somehow omitted data?
The question is, could you get too low a number? My first intuition was no, because if I'm only asking for a tiny little subset of the information, let's say somebody gave me 50K of text and all I want is the artist's name, then it's okay for it to be a tiny subset. It's just 2 pieces of data I'm looking for. So my instinct is no, but your use case could vary, and in this, the parameters are tunable. You can just change a custom function and change where you want the cutoff to be. It's an interesting question. So that's metric number 1, very old school information theory metric to say how much stuff is here, how much stuff is there. Obviously, then when we get over to the the place where we trick the poor AI into just this florid hallucination, this says it has 551 times as much information as the source, right? We knew that already, but it's nice to see it. Nice to see it reflected there, right? Because it's added so much.
So that's the how you're going to get into the per field evaluations, presumably. That's going to be one of the other mechanisms.
That's right. That's the other one. But this is just a quick overall take. And generally, if you're using a technique like that and it comes up red, something happened. Maybe something systematic. And then I think for some of these others, let's just take a look. I should have had a demo where one lands. Yeah, this one is still reddish, but we could take a look at this one and see what we think. In this case, the additions might be okay. So that is information theory concept number 1. This is concept of entropy. And again, content doesn't matter. It's not comparing anything about the content. It's literally just looking at how. So there are probably ways to fool it, but it's I think quite reliable for what it is there. Technique number 2. There's something called a similarity metric. And this is going to look a little bit deeper. And we're going to go field by field this time and say, all right, I want a subset of this, and I want to somehow assess, not just at the entropy level, but so it's great that it has about the same amount of information, but the information could be completely different. That's one thing that you could be fooled by. Because you could have, anyway, doesn't matter what you could have. It's not a good guide to whether the stuff that's in there was in the original. And that's what these metrics are going to do. There's something called a Jacquard index. It's also highly mathematical, but you can think about it this way. Let's imagine that I take, and I'm going to just step over to a nice picture there. It's not that easy to read. Let's imagine that I take all of the words in my source and distill them into a unique dictionary. So I have a dictionary, one entry for every word in the source. Then let's imagine I take a piece of the extract over here and I do the same thing. I say, get me a dictionary of all the unique words. Then I want to ask the question, how many of the unique words in my extract are in my source? The more that are in there, the more reliable I think the extract is. In other words, if 96% of the words in my supposed extract were in the source, I probably think it did a pretty good job of doing the extraction. Now, again, we could and can look under the hood at this a little bit. So let me just do this for grins. The point here again is not to impress anyone or to overly perplex anyone, but just to know that some of these things can be done. The custom functions for getting the total information content, they actually are based on some other custom functions that are using while loops and are also based on still other custom functions. These are fairly expensive computations because they have to read through the entire source text bit by bit. And when I first wrote them, they were groaningly slow and they weren't fit to demo. Based on some of the stuff Clay said about JSON yesterday, I think there might be some optimizations we can do for that, but I had to do a lot of work to speed them up. So these are fairly intensive computations. And the list compute similarities function is just, it looks fairly simple, but it's what's called an n-squared algorithm, which means it takes a time proportional to the square of the size of the input to do its work. So it's not terrifically efficient. And if you feed it 30, 40, 50K of text, you're going to wait a while for it to decide what it's up to. Lots of ways to optimize that, and this is not all about optimizing algorithms, but there are ways of doing that. Again, if you want to know more, Wikipedia Jacquard index, Wikipedia overlap coefficient, but it's just a big while loop that compares one set to another and says whether the things in one are inside the other. So that's what's driving these items over here. And if we even zoom in a little bit, let's see what's going on here. This says the overlap with the original source is 36%. Well, that's not zero. And this is background information. So maybe what's going on here isn't terrible. I look over here, I look at this. I might look at that and say, that's actually a useful summary. I'm OK including that in my database. I don't mind that. The subject matter, it seems to have synthesized that from the art description. If I want a synthesized art description, that's actually great. 60% overlap with the original source. So it's picked a bunch of words from the original, it's framed them out into a sentence. That just goes to the fact that the source data is a little bit terse. Here, though, it's added a birth date, birth location out of no place, but it's added the correct birth location. So again, if I want to include that, I can. If we look elsewhere, just to see what else we've come up with here. This is not bad. It looks like the condition is suspect. I'm not really sure why it's decided that this artwork is an excellent condition. We got to kind of sift through it. No, there's really nothing there. That might be data that we just say, you know what, we're not going to pass that through. We're going to keep that out of our database. On the other hand, the background information, again, 62% over, is that even 62%? It's so small I can't read it. 62, yeah. You know, again, that might be acceptable. That might be just fine. This one has a little bit more text, so it took a minute. Again, it's just choking on the artist's birth country. So at this point, with the combination of these metrics, what I'm finding for this use case is you have a pretty good eye into the reliability of it. You first of all have that overall sense of whether the whole thing's been fiddled with excessively, right? So you have that overall information content. So this is saying, okay, 0.91, I think 0.91 is pretty good. It's got about 9/10 the information in the original. It's preserved most of it, and it probably hasn't added anything. Most of these look fine. Here's a place you can see you've got to kind of watch things here because what I have here is a set of measurements in millimeters, 610 by 508. It just decided to translate those to centimeters. I didn't tell it to. The 61 is fine because the 61 matches the 61 and the 610. So it's very clear this is pattern matching. It's not information matching, because the 61 as an integer is nowhere in here. But of course, it chokes when it takes 508 millimeters down to 50.8 centimeters. This isn't in there. But again, if this is what you're looking for, you can just pass this through and say, I'm fine with that. We'll let those measurements go. The measurements are correct. Yeah. And this doesn't mean anything. You get a quick check, and then you can say, OK, it's good. I'm done.
You had that example where you deliberately misspelled a bunch of words.
Yes.
I'm guessing that would end up with actually correct and good information, but it would have a very low score.
Yeah, let's take a look. Everything here is correct. It's got the artist right. I have to know that, but if I'm validating that, I know something about art. The artist bio, it's taken it from nowhere. I don't think that the title is, it's picked a few words out of it. But yeah, you might look at that and say it's fine to pass it through. But if the test you're applying is, hey, this is a valid distillation of the original, it's not. But that's OK. So this two-pronged approach, I think, has a lot of potential here. That sort of, except for some wrapping up remarks, is really what I wanted to walk you all through, right? So first, that basic process of here's how I'm going to get information out of the LLM, but then even more importantly, how am I going to validate it? How am I going to decide whether what I found is actually something useful? So again, we've looked at this. So let's just sort of try to wrap up here with some of these considerations, and then we can jump into some questions here. Again, what we've done, we sent a rigorous JSON schema over to the back end. We got highly structured data back. But because we're worried about hallucinations, we use some older school information metrics to try to establish whether it's reliable or not. And the way that we're looking at this or thinking about this, if we're looking at two things: how much it overlaps with the source in terms of field by field, and then how much does the overall entropy look similar or less than what we started with. So if you have high overlap with your source and your entropy is pretty low, your entropy delta is pretty low, it's reasonable to trust it. Most of the things match, and the overall information content is about the same or less. If it's somewhere in the middle, or you're seeing a lot of narrative and synthesized data, you should probably verify it manually, and you might want to watermark some of the data as being LLM assisted. Just press a button or something that says, hey, this description was created, with LLM assistance. And if you don't have much overlap with your source, or the entropy delta is crazy, like 550 for the example we looked at, then you probably want to reject it. You probably have a flawed scenario where something amiss is going on. Okay. So to kind of pull these thoughts together, and then we'll have time for some questions. Structured data is still vital. You've still got to be able to put data into database fields. It still means something. LLMs can cross the gap, but they need validation. And my suggestion to you is to validate with something that isn't an LLM. Now, this could all be obsoleted tomorrow, because these are all problems that the LLM makers are trying to solve. But my intuition is that the problem of hallucination is going to stick around, and the need to validate is still going to be there. And so, again, to me, it's very much a trust but verify situation. So using non-LLM metrics, I would suggest, is the best way to do it. Balance hallucination risk with schema complexity, as we were talking about earlier. If you're going to try to do this, start with a small schema. Just start with the data you know you're going to need and see how reliable it is. And then if you have more and more complicated things you need to capture, add things into your schema and see how it goes. There's all kinds of ways to do this, and I didn't demo this. I could just show this very quickly, I guess, because it was on my list of things to look at. Let's just look. Where do you want to store those big schemas? There's lots of ways to do that. I have sort of a structured config file here that's all JSON. It has a million different things in it. It's got all my URL endpoints. It's got all those things in it. There's a set of scripts and custom functions that manage this. You can also have a resource table with one record for each of your JSON schemas and have a way to query for that. Everybody's got a way of storing resources in some of these hard-coded values. So that's a good thing to keep an eye on. But again, just balancing your hallucination risk with schema complexity, I encourage you to have some different schemas. I started with a simple one and then scaled it up, and you can just switch back and forth between those when you make your calls. This call is the simple schema. This call is the complex schema. The last thing I'm supposed to remind you to do before we take questions is to fill out your surveys. I know Rosemary is very focused on that. But that's what I've got. So happy to take any questions or follow-ups you may have built up. Question there.
In your initial data that you're going to analyze, are there practical limitations? Like, can I take a PDF of an owner's manual or a repair manual that might be 100 pages? Are there practical limitations to that?
Question is there practical limitations to the size of the input? The answer is yeah, very much. Every LLM has what is called its maximum context size. This varies and it keeps changing, but a 100-page owner's manual would be a lot to analyze directly. I would look for a different way to do that. Yeah. Right now. Yep. Yes, sir.
Each time you run the process, would you get different results?
The question is, each time you run the process, would you get different results? And this lets us get back to the question about temperature that I glossed over a little bit. Oh, once I get my screen back. For OpenAI, you can pass it a parameter called temperature. And the lower the temperature, a lower temperature is an indication to the back end that you want the results to be more consistent. Higher temperature is a license to innovate and improvise. It's not foolproof. The answer is there is always a chance that the same exact query is going to lead to two different results. That can happen because of random chance, because the models have a probability aspect built in. It can happen because the model got updated in between your two button presses. So there's no guarantee of repeatability. It's going to be close, but it may vary by a few words. It may vary by more than a few words. That's a basic hallmark of LLMs. Every time, it's like a human, every time you ask it a question, they're going to answer it slightly differently. The gist of it may be the same, but they're not going to answer it word for word the same way. So that can always change. But you don't care necessarily. What you care is, does it pass your test? Is it good enough? So, yeah, I too am surprised that we got as much variation as we did with that temperature there. That's just an interesting feature. Other questions? Yes, sir.
Have you considered putting in some constraints? You might say one of the conditions is to not create more words than the original source available, for instance.
Yeah, so the question is, have we considered putting some of the constraints into the prompts, like don't generate more words or more information than is in the original source? The answer to that is yes. The prompt I showed up there that was a little bit hard to read had some of those things in it, basically saying, please don't hallucinate. And the heck of it is, it either works or it doesn't. But if it doesn't work, it will swear that it obeyed you. But the point you're making is an important one, which is that prompt engineering is a big part of this. You want to instruct it that it knows how to work with structured data, and you want to give it some information about what to do, for example, with things like null values. So your prompt is important, is the lesson I would take from that. It's very important, and it behooves you to try different prompts until you get ones that give the results that you like. So if you try that and it works, then it's absolutely the right thing to do. Yep.
So what do you do with the results once you get them? And what do you do with the reds? Do you change the value? Do you fix it? You didn't go beyond that.
Well, for those things, I take it that the input data is just no good, right? I can't get what I want out of that input data because it's much too small. Those are records I just don't process, or I discard them, or else I try to see that maybe I loaded the data wrong and I got the original data extract wrong somehow. It's not going to get it wrong if it's in the original. In other words, if it's there to extract, it will extract it pretty well. So if I'm getting a lot of red, it implies that I just didn't give it enough information to do its job, and that's what made it make up so much stuff. So there I would go back and try to get better data. Yep. Lisa.
Steve, earlier in the presentation, you were talking about the entropy metric, and I think you multiplied it with the length. And for some reason, that didn't kind of click for me why that was a thing. Talk about that a little bit.
Yeah. The entropy measure is a measure of bits of entropy per character. So that's an average. But what I want to do is compare the total information content. So it only makes sense to scale it up by the length. I could have something that is, let me think of the right way to put this. If I have a very large text input coming in and a very small text output coming out, the text output could have the right amount of entropy per character, but it's so small that it's suspect whether it's giving me what I really want. I'm not really comparing, I'm comparing an average, and I don't want to compare the averages because the amount of information matters. I want to see if what's over here is physically smaller than what's over here, not on average, but in the aggregate, or larger. That's what's really concerning. So if I were just doing it at the average level, I could have a very small extract over here with much higher average entropy than what's over here, and that might set off the flag. It might say, hey, your entropy is too high. Well, no, because it's just a single word here. It took me a while to get my head around that, and I had to re-explain it to myself several times. So that was my question, too. It's like, why do I have to do that? So I understand that. Other questions there?
I know you said that your custom functions could be optimized, but are you going to share them anyway so that we don't have to re-explain to ourselves?
Oh, yes. Yep. Maybe someone else can fix them for me. Yep. That's my plan. Yep. Yes, sir.
You mentioned always basically having a human element for review validation.
Yeah.
The amount of data to be processed scales upward. You imagine setting some threshold of permissibility, saying this is good enough, let the machine, let the script or process pass it through.
I think you would have to. I think you'd run it in kind of human-assisted mode for a while and see what you get, and then probably just kind of open the floodgates if you really want to process 100,000 records a night. And then the proof of the pudding is kind of in the eating. Are you getting good enough data? It's not that the data in this scenario is correct to some absolute standard. We're only trying to get it correct according to the inputs. And so it may be that the inputs are a little bit dodgy too, and that's the best that you're going to get from eBay art descriptions. So at a certain point I can see, saying, hey, for the most part, we know that if you feed it terribly impoverished data, we don't get good results, but we're not going to do that. We're going to set a minimum of 500 characters of input, and for anything between 500 and 10,000 characters of input, we get really good results. So we'll just automate it and see how we do. Absolutely, yeah. These APIs do have batch modes. I didn't get to experimenting with those, but I would love to try. I think they could be great. Fun.
Just for fun, did you try like copying 2 paragraphs off a sports page or something that had nothing to do with art and see what it did?
I have not tried that. I have not tried that. I've tried different prompts. Another question I got was whether an AI could read pages from an art daily magazine and isolate the personal names to see whether any of them were artists of interest. It did a fantastic job with that. It was scary. I haven't tried that, though. I'll give that a try. Once I unplug this, I'll give that a try. Yes?
A couple of things that, like doing few shot bumping with it, give it a couple of examples.
Yes.
That also could improve the score, your automatics, give you more nulls instead of it filling in the data for you.
Yes.
And, if you're doing this for a large project, then maybe fine-tuning the model to
Yeah, absolutely. The point was about something called few-shot prompting, where you give a few examples of what you want to get back. And in fact, I've experimented with that with Claude, and it works great. It's a big prompt because you're giving it some samples, and then here's the JSON I expect back. But the results I get are fantastic. And the few-shot examples contain the schema, so you don't have to send it in the request like that. That's why this is such a moving target. So this is just using the simplest capabilities. Absolutely. Yep. Other thoughts or questions? Yes.
Entropy in physics is a measure of disorder. Is this a new definition of entropy?
It's an information theoretician's definition. A guy named Claude Shannon came up with it, and I can't exactly tell you why he chose the term entropy or how he chose it. It is similar in the sense that it speaks to the amount of randomness. It goes back to that idea that the higher the entropy, the more random it is. And as you're reading through it, can you guess what the next bit of information is going to be? If you consider the word elephant in English, now drop the T off. If you read those first 7 letters, you can predict the next letter with complete fidelity, right? Because there's only one word in English that has those 7 letters. So that's a low entropy situation. But some of the examples we looked at before, especially where it's already abbreviated, are high entropy situations. So I think that's the parallel. It's the degree of randomness. Randomness equals surprise equals unpredictability equals low compressibility. And so it's a pretty good high-level measure of how much stuff is going on here versus here. Two things that differ a lot in their entropy have something fundamentally different about them, which is why it kind of works.
I'm impressed that you could just answer like that to that. My brain just exploded.
Yep. There you go. Other thoughts or questions? Happy to take questions afterwards, but otherwise, thank you all very, very much for coming.